Hello, everyone, and welcome to the webinar with Expero and Imply. Today, we're going to be talking about detection of fraud and how we can do that in real time with analytics. With all of our webinars, we record these, and so there will be a link after the webinar that you can share with friends and colleagues. If you have questions during the session, there is a Q&A tab at the bottom, and then we'll save some time at the end for questions. And so if you want to enter your questions in there as well, we'll be answering those live at the end. All right, without further ado, we'll jump on in. So my name is Scott. I'll be sort of the ringmaster for today's webinar. I have with us distinguished colleague Rommel Garcia, who's part of Imply's engineering team, and then Brian Hull, who's part of the Expero analytics practice. All right, so I'll be kicking things off today. I'm going to talk a little bit about how and what we do, sort of why fraud is such a difficult problem, what we need to do to jump into why the technologies that Brian and Rommel are actually going to walk us through today. So very excited about sort of where we're going to end up today. With that, a lot of the practices that we're going to see today are elements that are part of what Expero and Imply have done in many different industries. So not just specifically in finance fraud, but other areas, the same kinds of approaches are very reusable, if you will, in sort of what the patterns are and kind of how we do these things at scale. So we'll see what some of those examples are today. The next thing that we can do then is, as we start to look at that, then is in the anti-fraud, it's tying together this machine learning and kind of what AML, financial crimes, and those kinds of things, et cetera. And obviously, Imply and Expero can help you do these kinds of things in other areas. But today, we're really going to be focusing on what those patterns look like. And then more importantly, we're going to show you some examples and then show you a little peek behind the curtain, if you will, about how we do that, which is typically most important. Okay, so as we start to look at what's going on in fraud today, what we can see then is lines of business are foes, if you will, are coordinated and adaptive. We can also see then that this is creating now, with the massive amounts of data, more false positives, or more human time is being needed to sort out all of this data now that we're sort of awash in. The other element then is regulations are changing. So how and what people are doing and where they're connected. And you can see down here that, we may see people skipping across countries and other kinds of rules and looking for loopholes, quite frankly. And what this really brings us then is this surge now of what fraud is in our world. And so increasing our throughput, increasing our accuracy, and decreasing those false positives are really sort of job number one. Now, there's many times different kinds of fraud, and that's what we see over on the left. So this constant sort of categorization, if you will, that internal fraud, whether it's a bad actor in our organization that's working with someone on the outside, or there are rings or anti-money laundering kind of groups that are going on there where they're laundering through what look like good goods and services and then creating the clean money. And many times credit card transactions can be tied to those as well. So whether it's individual line items, and you may be a retailer and you're on the other side of that, or you may actually be the bank or the clearing facility where those transactions are going on, in addition to false ID. So whether you're falsifying a loan or anything like that, or you're actually stealing someone's that already exists, et cetera, all of these different categories, including cyber and IoT and audit and compliance. And then finally, what you see is our law enforcement, right? All of these use cases are ever so slightly similar, and they can also then, by this center set of items that we're going to see today, then is how do I show this? How do I combine this with other technologies like a graph technology, right? How do I see the power of what an Imply can bring to the table, and then what can I see in a geospatial overlay, and then allow teams of people to actually go at speed in real time, which is really where we're seeing over on the third column over here is how do we find those? How do we prevent them going forward? And then we give the human something that's more decisive, something that doesn't allow them to go spend lots and lots of hours chasing wild rabbits to do those kinds of things. So this is really sort of the table stakes, if you will, for what we're going to chat about today. The next thing then is sort of turning it on its side, which is each of these different use cases that I mentioned over there. You see the dotted line and the hard line. Just because you may be in the money laundering group doesn't mean you may not have to interact with IoT or device or cyber or one of these other groups, right? And as our business partners see it over on the left, which is I need to increase my revenue. Well, allowing potentially falsely blocked transactions through allows me to make more money. So instead of picking something that looks like fraud and then blocking that transaction for buying that good or service, right? The other element then is this cutting the cost, right? So obviously finding fraud cuts cost and spending, those kinds of things, but that also overlays into sanctions, right? Which is if we can prove that we are doing a good job, perhaps we may not get that fine and those kinds of things down in the bottom, which can turn into risk, right? So real people in our bank or our retail organization, if we're not doing the proper kinds of procedures, right, people get in trouble, right? And we don't want to do that. So again, another view of this, but now starting to show this more complicated view of where Expero and Imply Technology can really step in. One of the other things that we'll see today when Rommel and Brian are walking through their sections is it's typically not the act of not using machine learning properly. Today, one of our customers, the funny anecdote is, a random act of machine learning violence. They have 10 to 20 full-time machine learning teams that are doing things in laptops on Jupyter notebooks and finding great things, but they're not all connected. And that is really kind of what we do here and where we're sort of talking about today is this ability now to create repeatable and scalable versions of this. How do we create this so we actually learn and get better in addition to allow novice investigators or people that are laypersons that can use the power that we'll discuss today at scale? Well, as you lay this down, now you see at the very tip, which is a human. There will always be a human. There is a need for a human. But what we want to do now is all this pyramid below that, which is creating insights, allowing it to be visual. And the new term is coined, which is explainable AI. How does data science and analytics fit into this? And that's really what, again, Imply does in our analytics, in our real-time sort of volume in the data layer. And then ultimately, how do we use these assets and infrastructure? How do we plug these into a much larger ecosystem? We have real-time streaming softwares, folks like Confluent and other folks like that. We have other kinds of graph databases and other kinds of interpretive and very complex, capable technologies like a tiger graph or those kinds of things on our graph side. And then ultimately at the very bottom is if our business doesn't get this in a timely manner and it doesn't meet their goals, then ultimately all of the cool things that we're going to talk about today don't really make any sense, right? We've spent a lot of money to do a lot of cool stuff, but it didn't really move the needle on lowering false positives or increasing the accuracy or quite frankly, finding the fraud and then preventing it from happening. So this is kind of how it all fits together. The next thing now is this really combination of what we can do in these different technologies. You see over on the left, again, this concept of a graph algorithm, which is an extension of what's over on the right. So how do I take machine learning algorithms and how do I bring those together? Well, the third part of that tripod, if you will, is going to be analytics. And that's what Rommel and Brian are going to walk us through then, which is how do we use both of these elements and now sort of really get it at scale with an Imply kind of a platform. Now, part of this is there are multiple users that are out in our world. So if we're in fraud today, executives want to see what the impact is. Where is the fraud coming from? How do I prevent it? What are the most current elements? And we'll see that here in a minute. We also see lines of business, which are typically one notch below that. They want to see what's going on in my ... AML line of business or my credit card transaction line of business, et cetera. where are those things impacting my investigators, as we see in the next couple of orange boxes down here, which is who is doing the investigation? Are we opening SARs? Are they connected to cases? Are those known associates, right? Where is that analytic element to go do that? And then finally at the bottom, we see data and analytics. And that's really where our friends Imply are going to weigh in, which is how do we synthesize this data? How do we look at terabytes and petabytes of data to be able to do those things? Okay, and this is just a quick layout of what I walked through there, which is find it, prevent it, and then ultimately what we want to do. And part of that now is this visualization capability that I'll give you a preview of here in a second. Now, this is complicated by the fact that we typically have large groups of teams, lots of individual teams that can't necessarily share with other teams. And this is kind of a need to know, if you will. And in some cases, these groups do work with each other. And so that ability then to sort of make it atomic and then allow it to sort of be connected to other groups. How do those groups build their own scenarios without sharing? And then when it is time, how do they promote it into a group or into a SAR or those kinds of things? And these are now these workflow elements. And this is really what Expero does now, is tying all of this great technology together, creating applications that are seamless that allow these teams to work together. And that's really what our demo is. And so now what I'm going to do is I'm going to step through really quickly. In this case, what we now see is what a dashboard might look like. And in this example, I'm looking at AML. Now, this could be transaction fraud, could have been cyber, could have been any of those other ones. And the tools that we build on top of this are really sort of data model and use case specific, and they basically work that way. Now, in this case, what I can see in the dashboard is I see some trends. And so maybe I'm an executive or that line of business person, and I can start to see, well, that's interesting. I'm seeing more people that are using false or connected device IDs. I may see communities where people are now either learning from each other, or perhaps they are rings of people that are working. You can also see that I have things called a spider chart or a risk graph, where I can say, in this case, where is the largest potential point of issue? And what I can see now is that it's actually in the transaction level here for the credit that's being sort of transferred perhaps back and forth, and where is that money going? I can also see incidents. I can see alerts and other kinds of things that can be brought to me by real-time or streaming information based on my source data. Now, as I step into this, I could now be perhaps a first-line investigator. And in this case, what I see is I see a transaction at the atomic level, and I can see now strings of those kinds of things that are coming through. I may now use this new technology platform, if you will, that can give me a signal or a recommendation or a data product, as we'll see here in a minute. And what's happening now is, in this case, I may get a recommendation from the new system that bolts onto an existing system, as we see here, perhaps Actimize. And it says, well, everything looks okay, but the new system shows something that's a bit more connected, or information now is showing me that I may want to dig in a little deeper. So what I can do then is I can actually click on this, and I can say, well, human, there are a couple of things that I have found for you. The first is these device IDs are connected to other fraudulent or suspected fraud in these communities. So I'm sort of telling you now that this is one of the reasons why. The second thing is over here, I can do a scoring or an algorithm, as we mentioned, from machine learning or from some of the other scorings that we can do, and say this particular transaction is perhaps in a country or in a location that's combined with a device ID that should not be there. So now I'm showing you, human, that there is a score on that transaction and its location that look out of balance, if you will. The other thing that we can see down here is a bit more. So that email may be directly connected to yet another email of someone who may be either under investigation or in a SAR. And then so on, I see now a phone number as well. So these are now additive reasons why, human, you should take note, and more importantly, you should reject this. And then the final thing is more of a heat map, which says, human, by the way, I now see that there are other transactions that are similar to this that are connected. Some of them perhaps were approved, or perhaps they should not have been, and they are connected in these ways here. So now what I see is a very strong case for why the human perhaps should find this as fraud. Now, here's our human, and he's in the loop or she's in the loop. And what she can do now is she can come in here and say, hey, I want to watch this. This is indeed interesting and anomalous, but it's not yet a SAR or a fraud case. But I do want to watch it. So alert me when this type of activity comes back in again, and maybe I will take action. So you can see here that if the human gives feedback to the system, now you can start to really sort of make it more powerful and stronger. So that is one of our vignettes. The second thing that I can do is I can start to see now what are those connections. I can see now good and bad transactions, right? In this case, I see that there is a shell company, and I see that there's a CFO, and I see that those two people are connected in a different way here for what those elements are. Now, I may want to view this in a different way. Maybe I don't want to see the human in the loop. I actually want to see more of a transactional flow to say, well, where are they coming from and what are those entities? So again, the toolkit that we provide actually has this alternate view. So what I've done now is I've allowed the human to say, well, there are a series of transactions that are indeed connected. It looks like there are people involved that are perhaps bad. And now I actually want to go do something. So that's our first vignette. The second vignette is something that we can do now where we can actually dig in and we can go look at that company and we can say, well, here's our friend again, Margot. We can actually see what she's doing over here. And now I want to dig in more at the investigation layer. Well, again, I'm using the power of all this other technology in the human way that shows these different connections. And I'm now able to dig in a little deeper and say, okay, now I start to see that there's a device ID in addition to the transaction where I want to do and investigate, and I only want to investigate those different elements. And now what I'm going to do is I'm only going to add those individual elements in yellow to the investigation. So now I can go forth and start to investigate at a deeper level, and then I see my friend the geography chart again. So again, what we're trying to show here now is the power of what Brian and Rommel are going to show us is easy. It's simple. It allows humans to actually sort of use that power that we're about to hear about in a much different way. So what are we trying to do here now? We're trying to increase that accuracy. Use your current tech. So if you already have machine learning and you have other elements in there, this is really more of a bolt-on system. Some of you may not have sophisticated systems, and certainly this could be the primary or the gold record. And then we see some of the other ones here, which is, decrease the false positives, increase our efficiency, and then continuously get better as we go through that. So with that, I'll hand it off to my colleague, Brian Hall.
Thanks, Scott. Let's dig a little deeper into how a lot of this stuff works under the covers. So no fraud systems start out with an empty database, right? You typically want to bring in new data that is comparative in some way with things that you already know. So usually we start with modeling your current corpus of data, and then align the new incoming data along a handful of parameters. So number one would be, what sort of electronic info do the new orders share with things that I already know, right? Oftentimes you have email addresses, you have IP addresses, cookies, that sort of thing. Secondly, you have some notions of physical information, either the name of the people, geolocations, other sorts of company names if it's AML, corporate identities, those sorts of things, and then we start getting deeper into the algorithmic side of the house, where we start computing similarity on the data, and then also bundling into communities. On the next slide, take for instance, if you've got a new transaction that's coming in, you've already identified historically suspicious transactions or suspicious people or suspicious orders. And I can come in and at the time that it comes into my system, I can compare it to see if this new incoming order or new incoming transaction has any shared features with something that I already know, right? So it's not so problematic if I share a name, particularly if it's a reasonably common name. But suppose a new order comes in that shares a cookie or an IP address or a phone number or what have you. Shared features on their face are not automatically problematic, but there is some heuristics depending on which features you happen to share. And certainly if I begin to share more than one of these features with somebody who's previously been flagged as suspicious, then that might increase my score. So I've immediately added to my corpus of information. I know everything about this order, and now I also know shared features against existing or previous orders. On the next slide, you'll see that after we do a summary of shared features, what we'll do is take this new order and compare it for a similarity calculation. For those data scientists out there, there's a couple different similarity algorithms. You can either do cosine or Jacquard or a handful of other ones, but in essence, what I might want to do, in addition to seeing all the features that I might share with existing orders, I want to compare this new entity against everything else that I know. And I can compute this in a floating point calculation and arrive at some sort of a similarity where this new entry can be compared to everything else that I already know. Taking that similarity, on the next slide, you'll see that you can take all of these similarity scores and then begin to bundle all of my orders or corporate transactions or money transfers, what have you. I can then begin to bundle those things into communities, and each of these communities on their surface don't mean anything other than these people are similar to each other, or these entities are similar to each other. On the next slide, I might attribute some sort of good community or bad community, right? So, for instance, if I have a new transaction that my community calculation suggests it would go into the blue community, I'm probably less likely to be suspicious of it. However, if it goes into that purple community, that might cause me to inspect it much further, right? So really, what we've done is with nothing more than comparing it against my existing corpus of information, I've now gotten two other pieces of data that will allow me to make better decisions on this new incoming transaction. Number one is the suite of shared features that I may have with existing good and bad orders. And then the second one is an algorithmic computation that suggests, that I'm either part of a good community or a bad community. So on the next slide, you'll see how we begin to take this. Up to now, we haven't really talked about machine learning in detail, but in essence, what you end up doing is you take these graph features, you extract them out of the graph, both the communities and the shared features, and then you insert them into your feature vector, and then run all the same machine learning analysis that you're already familiar with, right? So in essence, all we're doing is adding to the feature vector for a better or more thorough or additional inputs to my feature vector. And then, the results of that you'll see spitting out into the fraud toolkit, the one that you just saw Scott demo just a few minutes ago. So on the next slide, basically what we're talking about here is the fact that the kind of baseline machine learning that we've been doing for several years is traditional machine learning, and now we've got all of these additional input features to the vector, and this allows us for some improved accuracy. Next slide shows basic baseline accuracy that improves over time. And basically what we're saying is these graph features tend to add somewhere between 3 to 6% accuracy on top of the baseline machine learning. Next slide. One of the interesting additional approaches here that we wanted to talk about was a new academic paper called Midas. I have a URL down at the bottom here, those of you so inclined to read about academic papers. But going back to our previous example, where I've got new data coming in, and I've got an ability to compare it against my corpus of information that we've already walked through. But what we're going to talk about here now is adding time series to the graph attributes. So on the next slide, suppose, for instance, I have shared features that all come in very, very tightly in a tight time frame, right? That, in addition to the connective tissue of the graph, tells me that all of a sudden I've got connections that are happening all in a very short time frame. So what the Midas paper, for those of you who want to go back and read it, suggests is that another very powerful input feature is the time with which these connections are made within the graph, right? So what we're saying is baseline machine learning provides you some level of accuracy. Adding graph to it improves it a little bit more. And then what we're suggesting is that adding the time series feature is yet another additive feature. Next slide. So basically, continuing on the paradigm, you've got the same baseline set of input features from your traditional machine learning. I can now add a handful more through my graph convolutional network, and now I can add additional ones for edges and time series additions. So my input features and my vector is even broader and broader. Next slide. So what the research has shown is that I've got, in addition to the 3 to 6% that I'm able to add for graph analytics, I can now take 1 to 5% better on top of that by using the time series attributes. So those of you who are doing fraud detection or other money laundering approaches, you know that these are all approximations to perfection, right? We're trying to get incrementally asymptotically closer to perfect. So every additional attribute or every additional approach or technique helps us get closer and closer to the promised land. Next slide. So all of this has to happen, mechanically, and there's compute systems underneath the covers. A little bit about how we actually look at the world. You've got these data, data mapping and data sources coming from the left, and entity resolution, lots of machine learning in order to populate the graph and the implied data, streaming data sources. And then what you've got, and what Scott demoed earlier, was the front end visualizations that show you how you might be ingesting this from the user's perspective. Next slide. So what we're talking about here is the machine learning model and all of the efforts that your data scientists will put into this will be spitting out the list of suspicious or probably suspicious transactions that are worthwhile for your analyst to look at. However, we still want to depend on and leverage the expertise that end user might have. We call that the human in the loop, and Scott already addressed that quite eloquently. In the next slide, we talk a little bit about how that might work, right? So we've got these data sources that are coming in, feeding each one of the models, where we pull together a composite risk score. This risk score typically is done, we run it against some subset of your history, and then we realize whether or not we're close enough to get the results into the workbench, right? So those of you who are data scientists or work in this realm, you understand that there's an iterative process here. And then at some point, the analyst might be looking at this and rendering some verdicts as to whether or not our system is providing them enough correct positives and negatives to put it into production. Next slide. So how do we use this, right? So the machine learning model actually feeds from up and over to the user interface. The user feedback says, yes, I either got it correct, it's under or over the threshold. Should we refine our system by applying some or adjusting some thresholds? Are we incorrect that it is not fraud when in fact we incorrectly suggested that it might be, or should we be ignoring this? We'd like to filter out all of the false positives and false negatives if at all possible, right? Yeah. One of the most common problems in this space is too much noise for your analysts, right? You don't want to be giving them thousands and thousands of cases every day to try to inspect it. They would get drowned in the data. Next slide. So this, Scott showed you some of the front end development and front end application, but in essence, these configuration features are where we would actually provide feedback to the machine learning model, and consequently, this would help us refine and train it as it is operating longer and longer in the field. Next slide. And then what you end up doing is you can provide that input, provide it back to the model, and the model gets smarter over time. So the next slide. So what we're really saying is each one of these techniques is additive and improves on baseline by adding these techniques on a layered approach, right? Baseline machine learning that's been in place for several years, graph analytics and graph convolutional networks that have been new over the last probably decade or so. This new Midas and time series innovation is reasonably cutting edge, only published over the last year or two. And now we've got the additive ability of the human in the loop to provide unique subject matter expertise in your domain, unique to your business. So A plus C, B plus C plus D is better than any subset without the whole suite. Next slide. So that's a little bit about the approach. I'm going to hand it over now to Rommel to talk a little bit about how Imply plugs into this approach.
Thank you, Brian. A little bit about our company here. We were founded back in 2015. The creators of Apache Druid are actually our founders who back then worked at Meta Markets, and they saw the potential to actually have Apache Druid be used on the commercial side of things. And so we got incorporated in 2015 to commercialize Apache Druid, and backed by Anderson Horowitz, Geodesic Capital, and Costello Ventures. And we are headquartered in California, have presence globally across different regions, and have a global customer base across many different verticals, including financial institutions. As you can see here, we have several common household names like Amazon and Apple and Twitter as our customers. And then our technology is pretty much cloud native. We have our product in AWS as platform as a service, which is called the Imply Hybrid Cloud. It can be installed as well on-prem. And the core of our engine is actually Apache Druid, which provides high performance analytics for a lot of the queries that you normally do, especially finding out anomalous transactions. So essentially, with Apache Druid, I mentioned earlier, which was created by our founders at Meta Markets, which is now part of Snapchat. They created Apache Druid, and this was to solve their problem of speed and scale. They were reaching the point of having 2 petabytes of data set, and their analysts were wanting to access the data in the sub-second level. And so they tried a lot of different technology back then, but nothing has worked for them. And so they created Apache Druid. And so AdTech is the very first use case that Apache Druid actually solved. And then close to a year after that, once Apache Druid was open sourced, Netflix actually was the very first commercial company that adopted Apache Druid. Until this today, they are still using it for many different applications that help them understand customer experience of their product being used globally. And as the adoption increases, you can see here other huge tech company back in the West Coast, like Airbnb, Lyft, and Hulu, and eBay adopted it. And then we understood that there's a market for Apache Druid, and that's why Imply was formed by our founders. And now it's widely adopted in the high tech. And you saw earlier as well that we have customers, not only tech companies, but financial and other areas. As you can see here on the next slide, we will see many different verticals that are using our product today. Media and ads, that's a very natural fit for us, communications, retail, and so on. So very big names here across different industries. All right, so what do we solve? So you can see here that there are two classifications of problems we actually solve. One is on the business intelligence side of things, and the other is the operational intelligence. And these applications are actually mission critical, which either affects the bottom line or um, have an impact on how a organization actually does business, especially when they are bounded by financial regulators. And so our focus today is on risk and fraud, which we will talk about this in the succeeding slides. And that's one of the areas that we have a customer have used us for anti-money laundering use case. So this is an architecture for modern analytics. So if you hear the word modern analytics or replatforming analytical platforms, this is how it normally looks like. So on the left here in the green box, you see the data source, and that data source are then feeding the data into a message bus, which is your data delivery, kind of like Kafka and Kinesis. And then that data then gets fed to the data lake or your cloud storage for raw and long-term storage. And then that also gets fed into a data processing layer, which is your data pipeline for doing micro ETL or batch ETL using Spark or EMR and similar technologies. And that's mainly for enriching the data set that is available from Kafka. And then data output from the processing gets fed back into the data lake storage. But what's interesting here is the red box, as you can see on the bottom right, which we call the hot analytics, which is directly ingesting from Kafka or Kinesis, and then exposing the data for immediate analysis of the data. And you'll see a combination of, a hot analytics and cold analytics as well. And this is fairly common. We have customers where they're using, Snowflake or BigQuery from Google. We actually coexist with them. And the reason why we coexist is because data warehouse is used for a different purpose and very lax into the SLAs that analysts actually are requiring, but for very strict SLAs, Imply is a better fit. So now you have both layers, which is hot and cold analytics that serves the purpose of solving, two different problems. So anti-money laundering, as you heard earlier from Brian and Scott, it involves a lot of processes where human is also involved, but this is more of like a simplified version of it. Consider the activity here as your financial transactions. And then you have these machine learning rules that are currently running, and then it detects to see if this will be allowed or denied. And so black and white, right? But there are some gray areas where the machine learning model really don't know if this is a problem or not. And then that gets flagged and posted for case review. And that case review process is powered by Imply. And then the human can then find more granular details as to why this transaction it could be an issue or could be anomalous. And so the more data that the analyst can actually come through, then the better the decision that analyst can make. And so based on what that analyst is doing, based on what the analyst had found out, then they could change that decision, as you can see from the UI earlier from Scott's demo, where you can actually change a false positive into a true anomalous transaction. And so This is a process typically that we see where anti-money laundering is involved, and implies a fit for case reviews and also enabling humans to make changes to their decision. So this is based on one of our customers who's a bank, and so they saw the value of using a product like Imply and change their culture a little bit from finding out if transactions are actually anomalous. So, as opposed to being reactive to the data that they see, now they're being more proactive. And they have the system in place to have a better detection mechanism where there's less false positives and less false negatives. And then we could scale their transaction on a day per day basis, a minimum of 500 million events per day. We have customers where they actually even go to a trillion events per day, ingesting data from Kafka with 500 millisecond latency end to end. Now, you've heard of Brian and Scott, who are the machine learning experts here. We actually augment those kind of solution, providing that 1 to 5% of improvement to accuracy by using time series, because Imply by default is a time series platform, and enabling as well the human to actually come through some more details of from all the records that has been stored into the Implied platform. Will give them the flexibility of making decisions faster. And so now you get the benefit of the improvement of up to 10% of accuracy of detecting anomalous transactions. All right, so from the top, you see here the high-level process, starting from data collection and preparation, transaction monitoring, and so on, up to regulatory reporting. So this is the typical process, and within these processes, you have this different set of challenges. If you have high false positives, it means you have a very high and a sustainable cost of doing business. And then obviously you get impacted by heavy regulatory fines and brand deterioration if you have a lot of false negatives as well. And going down the list here, you will see that the revenue gets impacted if you don't have any kind of like real-time action capabilities. And that's very important, right? Because we saw earlier from Brian's presentation with Midas, where once you start ingesting data from a real-time source like Kafka or Kinesis, and you want to detect certain transactions to be anomalous on the edge, then you're actually improving your ability to detect anomalous transactions or suspicious transactions. And so without that capability, then eventually you are impacting the customer experience and also taking a hit on the revenue. And combining real-time detection and having a OLAP type access or query to your data, that would just make it a lot better, because you can actually look at the transactions in many different ways to make sure that you're not leaving any kind of transactions that's actually anomalous. And so you heard from Brian earlier about the global community network, right, where you define what group this transaction belongs to. These OLAP capabilities is actually helpful in that area, where you can find some commonalities on these transactions. What makes it even more difficult is the lack of unified information systems, right? And that's very tough because different systems might have similar data sets, but the delta might get big. And so the trust level with that kind of system is pretty low. And so having this kind of unified system actually helps a lot to maintain consistency in looking at the data. Now, the other thing too that is pushing the boundaries of existing system today is the growth of the data, right? We saw earlier that the loss for anti-money laundering amounted to even like close to 2 trillion from Scott's tech earlier. And I mean, that's driven due to the fact of all this volume of data coming in, and it's just way harder to find that needle in the haystack, right? Where it actually is a suspicious transaction. And then omni-channel as well. You have many different sources of information coming in that just makes it more challenging. And so monitoring those will be pretty tough. And then the lack of support for evolving schema as well, right? Where new technologies comes into play, new applications comes into play, and they generate different type of data, and so you have to take care of that as well. And so you got to have a system that would allow you to be shielded from all of this evolving schema. So Brian and Scott heavily focused on machine learning, and now we're augmenting that with all-up as well, which we now call the all-up mining. And so with Imply, we are used actually as the backend for training the models, and then also exposing all of this raw transaction so that the analyst can associate different type of transactions. And then going back to that global community network, right, where you bucket each transactions to be suspicious or not. And then you can actually compare different transactions, for distinguishing false positives from true false positive transactions, and identify outliers as well. And many more, right? As you can see here, time series is a very important component to it because of the trending that you have to factor in, especially for the Midas solution that Brian actually shared earlier, where it's heavily dependent on time series. And so by providing time series information, then you are able to detect from the incoming data set at the Kafka platform if those transactions coming in are actually anomalous or not, based on the time series nature of the data. So this is the architecture of our customer. They actually shared this publicly during our Druid Summit, and so I'm sharing it with you as well. To the left, you see all of these different records or systems or data sources that are publishing events into Kafka. And Kafka becomes the real-time data delivery to many different downstream systems. And so this data then gets into Druid, where Druid ingested and apply all sorts of aggregation, creating the metrics or synthetic dimensions, and that then gets exposed to the system of intelligence, which involves reporting and dashboarding. You saw the UI earlier from Expero. That could be one of them here, where it will query data from Druid or Imply. And you've heard of graph databases as well. So in the anti-money laundering platforms, you always see graph database to be in there, and also machine learning. And that's because you would have to establish the relationship, between different transactions or users or company or entities. And then Druid would augment that to provide more intelligence around the edge using the Midas approach, and also giving the users the ability to run OLAP queries on raw data sets that are actually stored as well into Imply. So how do we then make the customer experience a lot better? Well, Imply and Expero can be used together to give the customer that extra boost for making the detection of anomalous transactions better. When you saw earlier that the benefit that you can get actually goes up to 16% improvement. And so having the combination of Expero solution and Imply gives you that 16% improvement to detecting anomalous transaction which helps you reduce your false positives and false negatives, and eventually helping you, increase your revenue, and then decrease the fines that customer normally gets without this kind of solution. And so all of the data sets that are available in Imply, may it be raw, metrics, and time series, are available for querying from the Expero platform using REST API queries. All right, so that's it for me. And I think we're ready to take questions here.
Great. Thank you, Rommel and Brian. A quick question had come in for you, Rommel, which is, can Imply work in the cloud, or is it on premise, or can it work as a hybrid?
Yep, great question. So Imply can be installed anywhere. Can be installed in the cloud, on bare metal, on like a virtualized infrastructure, or via a Kubernetes infrastructure, where if you're using Docker containers, you can also deploy Imply on these kind of environments.
Okay, looks like there's a follow-up question, which is there an average size of hardware or footprint that would be recommended for a terabyte of data?
That's a great question. For a terabyte of data, when it comes to sizing a cluster, it's not really just dependent on the storage of the data, because with a platform like Imply, you're typically CPU bound. And so you have to factor in, how many queries per second you can actually expect to run in your platform, how many users, how much data it's actually querying, and also the time range, right, of your query, not just the size of the data, but the time range. And so all of these factors then into what your cluster sizing would be. Now, if you ask me what the minimum is, you will have obviously, 3 nodes for your masters, which are responsible for keeping the state of your Imply platform, and then another 2 or 3 servers for doing the indexing and storing and providing power for querying the data. So it all depends on these different factors I mentioned earlier. And so you could start with this, 5 or 6 nodes, and then go from there to see if you need more firepower to meet your SLAs. And then if your SLAs are met using this, 5 nodes, then you're pretty much good.
Okay, great. We got one more question here looks like for you, Brian, which is your diagram of a combined scoring engine. How and sort of where, and I guess maybe Rommel's diagram is maybe another overlay on that, to actually how does that work, and where does that fit in the diagram?
Sure. So if you took nothing from today's session other than this, is that it's very additive in the sense that graph is very helpful, and time series and Imply is very helpful, and the two of them together is even more helpful in this realm. So what take for instance, graph is terrific with respect to shared features for, I happen to share an IP address or cookie with so and so and so and so. Calculating that on the fly and very quickly, graphs tend to be very good at. What they tend to not be very good at is things like, how many connections have I created newly with a fraudulent actor in the last 30 seconds or in the last month and a half? If my machine learning algorithms suggest that shared features incurred over a period of time is much more impactful in my machine learning routines than, if it's extended over 6 months, then I need to know that on the fly. So what we would be doing is ingesting both data into the graph and then maybe pumping it through Imply to actually allow us to calculate durations or average latency between shared features computation. So that's how we would be using some time series calculations coming out of the Imply platform to feed into graph features into our graph. So that's typically how we would use it.
Fantastic. Well, it doesn't look like there's any more questions. So I want to thank you guys today, and obviously thank you for everybody attending. As mentioned previously, there'll be a follow-up email with the recording, and please share with other practitioners or folks that might be interested. And everybody have a great day.
Thank you, everyone.